Hello, everyone, and thank you for attending Hyde Marine's webinar, Ballast Water Treatment Installations, Lessons Learned. This webinar marks the third of several webinars that were hosted by Hyde Marine. Please check out our website periodically for topics, date, and times of upcoming presentations. If you have questions during the presentation, please type them in the question box and direct them specifically to the host. After the presentation, we will try to address as many questions as possible. This webinar will be recorded and posted on our website. Please visit us at www.hydemarine.com or at our Facebook and LinkedIn pages for up-to-date ballast water information. Please note that this presentation contains historical information and forward-looking statements and includes Hyde Marine's interpretations of the landscape. Our speaker today is Mr. Mark Riggio, Product Manager at Hyde Marine. A graduate of the U.S. Merchant Marine Academy, Mr. Riggio started his career as a surveyor for ABS. He also worked for Crowley Maritime Corporation as a port engineer and later operated his own consulting company. As port engineer of the MV Cape Washington, Mr. Riggio helped design the first permanent shipboard ballast water testing facility as part of the Merck development team. At Hyde Marine, Mr. Riggio works very closely with all development efforts of our products and has very intimate involvement in the regulatory approval process. It's my pleasure to introduce Mark and pass the floor to him.
Thank you, Adrian, and good morning, everyone. Welcome to the third webinar in our three-part series. Today, I want to talk to you about some of the lessons that Hyde Marine has had the opportunity to learn during the last 10 years we've been in the ballast water treatment system market. It is my hope that these lessons will be helpful to others as we approach the upcoming retrofit market. During today's session, I want to spend some time reviewing what owners should be considering when selecting a ballast water treatment system. What are some ideas for how to plan trouble-free operation and installation? And then I want to walk through some key installation do's and don'ts. I will also spend some time talking to you about the maintenance requirements for ballast water treatment systems. And then finally, I will share some of our experience about common engineering mistakes that are made at the beginning of the planning process that can impact the overall success of your retrofit. We have a lot of ground to cover, so let's get started. So, what should you be considering when selecting a ballast water treatment system? First, you need to consider the challenges of the upcoming retrofit installation cycle. Once the IMO convention is ratified, the timetable will be set for the retrofit of over 45,000 ships during a staggered 5 to 7 year period. As we discussed in our first webinar a couple of months ago, the longer the ratification of the convention is delayed, the tighter this schedule becomes. Ratification will most likely occur in late 2014 or early 2015, and once the convention comes into force 1 year later, the pace of retrofits will likely exceed 17 ship commissionings per day for the world fleet. Considering the current pace of installations in the world market, that is a staggering number. In order to have the best chance of successfully achieving this, owners must select a system that best matches their vessel design, the needs of their crews, and select one that fits in the location where the system is planned to be installed. Owners typically want the treatment system design to match the needs of their ship, but as we will see, this is not always possible. As demand ramps up and supply becomes more constrained, some owners may be left struggling to adapt their ships to whatever system is still available within the time frame that they need it. Although this may be a review for many of you, I want to take a quick minute to go over the technical design of treatment systems. There are some new names on the guest list today, and many new project managers are seeing these systems for the first time, so please bear with me. Treatment systems are typically made up of two stages, a physical separation stage and a disinfection stage. Some systems have multiple stages, but ultimately each stage can be classified as either a separation or a disinfection stage. The separation stage is typically made up of some type of filter that removes the larger organisms and particles, and the disinfection stage consists of one or more components that inert the remaining organisms in the ballast water. In order to keep this section relatively brief, I will classify the disinfection stages into two broad categories: chemical disinfection and UV disinfection. Chemical disinfection systems utilize some type of direct disinfectant that is either created from or added to the ballast water to destroy the organisms in the flow. This type of system covers both electrochlorination, advanced oxidation, ozone generation, and hydroxyl radical generation systems, as well as the pure chemical injection systems. These treatment systems have many advantages and some disadvantages dependent on the vessel and the application. In general, chemical systems are highly effective and have the advantage that the treatment system can be installed outside the space containing the ballast pumps. Chemical systems also typically provide residual disinfectant that remain inside the ballast water in the tanks after the initial treatment. One key disadvantage of chemical systems is that most require some sort of a discharge analysis and neutralization process in order to ensure that the discharged ballast water meets all local safety and health standards. The majority of non-chemical systems use UV light to disrupt the DNA of the organisms in the ballast water, which renders them harmless to the receiving environment. In effect, they remove the organism's ability to reproduce, so they cannot form an invasion of the receiving water body. UV systems are also very effective at treating ballast water. UV systems are affected by the quality of the water being treated, as well as by any dirt in the fluid or any staining of the water. They do have an advantage in that they do not change the water chemistry in any way, so they don't require neutralization. UV systems, though, leave no residual disinfectant, so typically UV systems treat the ballast water both on uptake and discharge in order to help ensure owners achieve full compliance with the convention. There are other types of systems that are used to treat ballast water, but again, for simplicity, I will focus on UV and chemical systems, as they make up more than 90% of the systems sold to date. Once an owner has selected what technology for the system they want to install, there are a number of other criteria that should be looked at. What are the operating costs of each system? Are there any minimum hold times that are required for full treatment of the water? Does the crew require any specialized training? Are there any operational restrictions like water quality, temperature, salinity, or other parameters that are critical to the operation of your vessels? Finally, tucked in the middle of most lists are the selection criteria is the maintenance requirements and maintenance intervals of a ballast water treatment system. While this is often one of the smaller factors considered, I would contend that for most owners, this is the factor that would most affect their long-term experience with a treatment system. Looking at the maintenance needs of individual systems, how much direct involvement is needed by the manufacturer, and how much can the crew do themselves must be part of this evaluation factor. The scheduled time between each maintenance and the cost of spares should be carefully considered. It's also important to consider the complexity of the system and how easy it will be for the crew to do the maintenance. What sort of documentation is provided? Each of these factors will be critical to the long-term maintenance of the BWTS. Finally, it's also important for owners to plan ahead to make sure that the system is installed in such a way that it can have the best chance for trouble-free operation, and that the maintenance needs and intervals do not get negatively influenced by these installation factors. Let's talk a little about how we can plan for that trouble-free operation of your ballast water treatment system. Over the last 10 years, Hyde Marine has had a lot of experience fitting ballast treatment systems onto ships. One key thing we've learned is that owners want to adapt the ballast water treatment system to the vessel design. While this sounds like a simple and logical thing, It's very important to understand that ballast water treatment systems are designed around a set of very rigid regulations with no margin for error. As a discharge standard, the convention requires a high removal and disinfection rate, and any flaw in the installation or operation of the system can adversely influence system performance. Simply saying that we've always done it this way is not going to be good enough once compliance testing starts. Although a number of systems have been installed, the lack of enforcement has created confusion about the requirements and how well systems are really working. Many systems have never been compliance tested, and as such, it's important to learn from the few that have been tested in order to protect installations into the future. At Hyde Marine, we take special pride in protecting our customers. We have learned that customized flow paths, additional valves, modified operating modes, and other vessel-specific customizations can have unintended consequences for system performance. Again, ballast water treatment systems are designed for a removal rate of 99.99% of all defined organisms under the convention. This very high performance standard leaves no room for error on the part of either the operator or the manufacturer. As shipyards and installation contractors have learned how the systems work, many systems may have been installed in ways that may impact that system performance. This may be because the filter drain line has too much back pressure, or the piping has been cross-connected to other systems. This may be because the system has not been designed to create laminar flow, or the system monitoring devices like the flow meter or the pressure transmitters may be located in the wrong place. Any one of a number of things can go wrong, and it's up to the commissioning engineer to ensure that the system is installed correctly. The critical point here is that customers don't always know what the system needs in order to operate correctly. It is incumbent on the manufacturer to ensure that the shipyard or installer has sufficient guidance to install the system and that the system is installed in accordance with these guidelines. A failure to do this, installing to the guidelines of the manufacturer, will impact both the manufacturer and, unfortunately, the operator. Failures of the equipment to work properly, no matter what the cause, reflect poorly on the system performance and the manufacturer. Warranty claims and other goodwill claims, regardless of fault, are perceived as failures of the equipment to operate in the marine environment. More than this, though, is the reality that incorrectly installed or incorrectly operated equipment can be dangerous to the ship or to the crew. It is the responsibility of the ship owner and the manufacturer to conduct a hazard identification analysis on the system and ensure that the design is as safe as possible. As the regulations come into force and ballast water treatment becomes a requirement rather than an option, the downtime that a vessel experiences due to system failures will become more and more of a problem for operators and more taxing on the manufacturers. Now I want to take a look at some of the installation do's and don'ts that can help set up your system for a lifetime of proper operation. One of the most prominent installation problems we see is sizing a single ballast water treatment system for multiple pumps. While this is a good way to save a little on the installation costs of a system, there are a number of problems that can be encountered when designing your treatment system this way. For starters, most treatment systems are designed for full flow of water through the pipe. By varying the number of pumps run, as well as the inevitable variations in the discharge rate of each pump due to changes in draft and the incumbent changes to the suction and discharge head on the pump, treatment systems can easily have their treatment rated capacity, or their TRCs, exceeded, or conversely, the piping may or may not be full when you run less than the maximum number of pumps. Treatment systems with limited power settings will operate at a much higher electrical consumption rate when only one pump is in operation than would be necessary to treat the flow from all of the pumps. Finally, vessels with only one ballast water treatment system will have no redundancy if there's a problem with the treatment system, and may have to stop ballasting rather than simply being able to slow down their ballasting or shift to single pump operation or shift to a standby ballast water treatment system. Other problems we have encountered is when ships tie their ballast water treatment systems to a high lift pump where the deadhead discharge pressure of that pump exceeds the pressure rating of the treatment system. This situation can occur when a treatment system is connected to a general service or fire pump, or alternately when a ballast pump may be used to move technical water or for any other high lift type of services. During warm-up, cool-down, and alarm conditions, or if the crew were to make sudden valve movements, there is a possibility to create deadhead conditions on the pump where the pressures can increase quickly. Without an open flow path, these types of pumps can create dangerous overpressurization in the piping. One other key issue we have encountered is the ship operator's desire to install manual isolation valves throughout the system. While these valves may be useful for maintenance and other non-routine tasks, if these valves are not locked open and remotely monitored, they can isolate flow to the treatment system and potentially damage the equipment. Again, in theory, these are all fairly simple, normal practices in shipboard application. But each can have a potentially dangerous, unintended consequence that, if not foreseen and addressed, may cause serious damage to the BWTS or the ship's piping systems. Let's take a look at a few examples. Here's an example of isolation valves being used upstream of the reactors. It's a beautiful installation, but if those manual valves are closed, the reactor may have no flow going through it. As these particular systems are installed in the pump room of a tanker, there are additional concerns both from an overheating issue and from diverting potentially too much flow through the other leg of the treatment train. Some other problems are a little more subtle than that. Take, for example, these two systems. Two Hyde Guardian systems, each installed on sister ships, installed at the same shipyard. Both systems were identical when they shipped from our facility. You see any issues? Let me show you. The flow arrows on each reactor are different. Although both systems were installed correctly, what will the ship's crew do when they notice the problem? Will they flip the reactor so the arrows are right, and now the flow is backwards through the reactor? Or will they simply change the arrow? Again, after reviewing the shipping photos from our factory, the arrows were installed correctly. But one was inexplicably changed during installation. During the commissioning, paying careful attention to details like this can help to make sure that the ship has the best chance to have trouble-free operation of their system. Finally, it is important to remember that ballast piping systems are not standalone systems. Most ballast piping systems can be cross-connected with numerous different piping systems on the ship. When ballasting, particularly when doing compliance testing, it is important to make sure that the lines are flushed from any bilge, fire water, gray water, or general service applications that the piping may have been used for that may contaminate the samples which supposedly have been taken from the ballast system. Careful consideration of the cross-connections of piping systems will go a long way to ensuring success when you face field testing in the future. Now let's take a few minutes and talk about maintenance planning. Every system on the ship, from the main engine to the emergency generator to the marine sanitation device, requires some maintenance. As with all other equipment, proper routine maintenance significantly reduces unplanned maintenance, but it does not completely eliminate it. Most ship systems and all critical equipment on ships have redundancy built in to make sure ship operations can continue uninterrupted by routine maintenance, planned or unplanned. Why is it that most owners don't consider ballast water management the same way? Obviously, the easy answer is it's because systems have a high capital cost. But the reality is, once enforcement starts, it will become critical to know what the cost of ship delays due to unplanned maintenance on ballast water treatment systems are relative to the increased capital costs of buying a system. Further, it's also, you need to consider what the cost of delay in cargo loading may be relative to the cost of installing a redundant ballast water treatment system. Particularly when that difference is the difference between buying two smaller systems rather than buying one larger system at a higher cost, incurring some of the problems that we've mentioned before. Every treatment system needs maintenance. It is important to discuss maintenance schedules and maintenance needs with your provider during the selection phase. It is also important to consider how much of the maintenance the crew can do and what needs a technician. Technical support may be available at ports around the world, but ships ballast before they enter port, and some ships may need the ballast to get into port. This needs to be carefully considered. The regulatory bodies may mandate certain maintenance intervals, particularly for critical instrumentation. These regulations are still ongoing at this time. It is important to have a good idea about what types of critical instrumentation exist for each technology, as well as how the manufacturer plans to recalibrate or recertify this equipment going into the future. At Hyde Marine, we have undergone ISO 9000 certification by DNV. As part of that process, we monitor and track our maintenance and warranty spend in order to improve our product and ensure we are meeting our customer needs. Our service department provides monthly, quarterly, and annual updates, and our high offender items are replaced or designed out of the system in order to improve performance. In 2013, for example, Hyde conducted 88 service visits, including 36 new system commissionings. Now, this means we conducted 52 independent service visits. To perform this work, we used 14 different technicians and 10 different service companies. We could have handled all of this work internally, but we are working to sustainably grow our service network, and we wanted to distribute the work among all of our partners. Additionally, in 2013, we trained 5 new service technicians to join our ranks. As you can see from this chart, we conducted about 42% of our service visits with direct Hyde personnel. The remaining 58% were done by our authorized partners in every region of the world. Again, by limiting the amount of service calls each group gets, we are steadily growing the base of technicians with field experience to serve our growing fleet. It is far more important for us to have a wide network of experienced technicians available in every corner of the world than to have a few key, highly experienced technicians who may have trouble responding to immediate vessel needs in the far-flung ports of the world. In order to handle this worldwide service network, we utilize a central database for tracking all of our field service activities. This database is accessible to all of our authorized partners, and they have access to the full history of a vessel from the original installation and commissioning through every service call and parts purchase. This central system allows us to manage our service network as well as to track global issues for faster turnaround on underperforming parts. It also allows us to track where equipment is and where it is installed in case we find issues that need to be addressed proactively. In case you're wondering, since we began tracking our warranty information, we have less than a 2% spend on warranty, which is less than the industry average for capital equipment. Further, using these systems, we've been able to reduce our warranty spend each quarter since we began tracking. This optimization has been a direct result of this continuous feedback loop and are driving product quality and design by monitoring issues in the field. One last note of caution on maintenance. All spares are not created equal. Ballast treatment systems are certified with very specific components. Changing these components with non-OEM parts may have a significant effect on the results of any compliance testing that may take place. Although many filter meshes, electrodes, and lamps may look the same, they probably will not function the same in your system. Let's take a look at one example of how much variation there is in these common components. When we were looking at alternate suppliers for our UV lamps, we performed a full spectral analysis of the different major lamp manufacturers. These are all the top manufacturers in the field of medium pressure UV lamps, and each of these charts represents the use of a lamp in our ballast and our power system combination. So utilizing the same reactor, the same sleeves, and the same power circuit. Now these results are for each different lamp tested in our reactor. Although these curves look pretty similar, let's take a look at one of the peaks to see how similar they really are. As you can see from this closer view, the lamp outputs vary significantly from the lamps used during our IMO type approval testing. Using a lamp with a lower irradiance will reduce the amount of dose applied to the water and may limit the effectiveness of treatment. To the naked eye, these lamps would look very similar, even identical. It is important to only use OEM-approved spares in order to make sure that you are treating with the same effectiveness that the manufacturer tested with. I know it seems like I'm repeating myself or trying to become a spare parts salesman, but this is an important point. As the industry begins to take off, numerous gray and black market suppliers for equipment spares will emerge. Instead of using inferior parts, it is important that ship owners take care to carefully look at the maintenance intervals of the systems they buy. What I mean by that is, many treatment systems use hour-based maintenance, and many ships prefer a time-scheduled maintenance. What that means for ballast water treatment systems is that many system components will be changed out every 5 years just because, even though they have not exceeded the manufacturer's recommended hours of operation. For many ships, the 5,000-hour life of our lamps represents 10 years or more of operation. Instead of saving money by using non-OEM parts, consider only replacing parts when needed and using OEM parts for the best life and the best performance. Before we wrap up, let's take a look at a couple of things you can do as you get started to help get off on the right foot. As we have discussed in the previous 2 webinars, planning for implementation of ballast water management is critical. The first step in this process should be bringing all of your internal stakeholders together and writing your ballast water management plan. Remember that the ballast water management plan is the document that's required by the convention that provides guidance on how your vessel plans to manage ballast water and ballast water treatment. By starting with this plan in place, it is much easier to make sure during your selection of a system that you address all of the needs of the vessel, the crew, and the operations department. Too many companies pick a system, install it, and then start to think about what their plan should say. Starting with the plan will help formalize the process and make sure you have thought of the critical steps ahead. Secondly, when making your plan, make sure that you plan for the inevitable failures. Have a developed section for dealing with maintenance and equipment failures. Decide how you want to handle system alarms and shutdowns. Do you want the system to automatically bypass itself and keep ballasting, or do you want the system to shut down? Allowing the system to continue to ballast will allow partially or untreated water to get to the ballast tanks. Shutting down the ballasting without a redundant system can create a slowdown or a shutdown of cargo loading and may even create a dangerous stability situation if the ballasting is not being closely monitored. Either situation can have a significant effect on the ship's operations and the ballasting process. Does your vessel want to do gravity ballasting? Do you need to internally transfer ballast? How do you use the aft peak tank? How critical is tank stripping? How will the vessel handle situations when the ballast water treatment system is working properly but cannot treat the water you are in due to the changing or due to extremely poor environmental conditions. All of these factors should be addressed during the system design phase so that they don't become an issue when the system is installed or when a regulator is asking to draw a sample. The test is coming. The U.S. regulations are already coming into force, and the IMO convention will likely be ratified within the next 12 months. The time for delay is essentially over. Many systems have been installed that have never been operated, and others have been installed that may or may not work with the current and developing regulatory landscape. We at Hyde Marine have been blessed with an abundance of owners who are using our systems and providing us valuable feedback to improve our product and increase our awareness of the special needs of the marine environment. I appreciate the opportunity to speak to each of you today and share some of that experience. So hopefully, what we've learned can help you avoid some of these same problems in the future. Owners that plan ahead and build a realistic compliance plan into their implementation projects will have an excellent chance to successfully navigate the challenges ahead. Are there any questions?
Thanks, Mark. If anyone has any questions, please type them in the Q&A box directly to the host, and we will try to answer as many as possible. The first question we have is, can equipment used in the ballast water treatment system be tailored to our spec, i.e. IP rating of a motor?
That's a good question. As we talked about earlier, there are many owners want to drive systems towards the approval or towards what their ship requires. We have striven to achieve all the class requirements, and we have a number of certifications that meet both the IP ratings of the installed areas and such. But it's important to understand for vessels that require specific tailored solutions for their service due to a particular need, for instance, a chemical carrier that wants to carry a particular type 2C gas that may require a higher IP rating, that they talk early with providers, because as the market begins to get more and more heated up and there's less and less time to deal with custom systems, more manufacturers are going to be forced to sell standard equipment, and then ships are going to have to tailor that. And it may be increasingly difficult to find the ability to be able to create customized systems for specialty ships and specialty ship classes.
How important is a UVT monitor to ramp up and down the lamp?
So a UVT monitor, for those on the line, is a device that's used to measure the transmittance of UV light through the water column. UV transmittance is only one of a number of factors that affects the amount of UV light that's transmitted into the reactor. So, in essence, UVT is a good measurement, but it's not the best measurement of how the UV performance in an active water stream is. At Hyde Marine, we prefer to use a UV intensity sensor that measures not only the UV transmittance, but also the amount of scatter that's in the water due to dissolved particulates. It also measures the amount of dissolved, it also is a de facto measurement of the dissolved organic carbon, and also measures the quartz sleeve fouling and lamp life degradation that does exist toward the end of lamp life, where the lamps begin to dim very, very slightly. By mapping this intensity to a certain point in the reactor, a very specific point, we can calculate the dose that's being applied throughout the reactor based upon the computational fluid analysis that we do for all of our reactors to prove our dose distribution. And so it's more important to look at how much light is being transmitted into the reactor rather than the ability of the water itself to transmit, because that's only one of a number of factors that affects UV performance. Hopefully that answers your question.
Does a bypass valve open upon plant failure?
The bypass valve opening on plant failure, in accordance with the Ballast Water Management Convention, all ballast water treatment systems must be capable of bypassing themselves in the event of an emergency. And so our interpretation of that section of the code is that it's up to an owner to decide if they wish to have the bypass valve open or closed during a shutdown or an alarm condition. As we talked about before, allowing this valve to open allows ballast to continue to flow, therefore not creating a dangerous situation on board the vessel. But it does create a situation where there is potentially untreated water that's going into the ballast tanks, or in the event of discharge, untreated or partially treated water that's going overboard the vessel. For vessels that elect to close off the B5 or the bypass valve rather, those owners do have to carefully monitor ballasting to make sure that the expected ballast flow doesn't suddenly stop and create a problem for their vessel, or that they provide a trapped path for positive displacement or high lift pumps that can create overpressurization. At the end of the day, this should be an owner's decision to make and should be submitted as part of their ballast water management plan to the Flag Administration for guidance on whether their plans meet the Flag Administration's guidance. Our systems are selectable so that the owner may make this decision, and it's something that we'll work with owners as far as that development of that protocol. But it really is an owner's decision based upon the risk and the operating profiles of the vessels in question.
How many of your installations were retrofits?
I believe we have over 30 retrofits. It might be another bigger number, but at this point, that's the number I feel very comfortable with. Again, we have about 30 installations. I think we've got maybe a little over 50 projects that have been sold for retrofits. Adrienne is waving her hands at me. She has better access to that information than I do. So,
what's the status of U.S. Coast Guard type approval testing, and when do you expect to have type approval?
So the U.S. Coast Guard type approval testing is obviously one of the big things that's ongoing right now. As we've discussed, I think we've had this question in almost all three of the webinars. So if you're testing my answers from the previous webinars, I applaud you. At this point in time, we're continuing to work with the Coast Guard to develop an alternative test method to what's defined under the ETV test protocol. For the layperson, the ETV test protocol mandates a particular type of stain that measures only the capability of an organism to respirate and process food. It does not actually measure its ability to reproduce. As the UV, as we talked about earlier, does not necessarily induce immediate cell death, but it reduces and eliminates the cell's ability to reproduce, thereby creating it harmless in the spirit and in accordance with the letter of the regulations. But it's a little more difficult to measure. And so once this is resolved, we have been working with the DNV independent laboratory, and we've completed our initial suitability tests and designs, and we are ready to start testing. But until the U.S. Coast Guard accepts a test method that would adequately show how UV works, we are continuing to work with them to do so. So hopefully that answers your question.
How does Hyde Guardian adjust lamp intensity, cutting lamps on and off, or adjusting the voltage?
That's an excellent question, and it's one that's an interesting point within the industry. I will defer to answer how Hyde does it because that's the way the question was asked. Hyde utilizes a two-stage power process, meaning we start out at a low power setting, and as soon as the lamp intensity sensor drops below 70% of the measured intensity, as per what is expected in the reactor, it shifts to a high power. Once that drops again below 70%, then there's an alarm that goes off that indicates that we're not treating effectively. But we use only two stages of power as opposed to an infinitely variable power supply, largely due to the complexity of those supplies and the requirements of the marine environment and wanting to use a robust and seaworthy application of UV power. Hopefully that answers your question. If not, please ask a follow-up.
Some ballast water treatment systems are approved for a certain minimum UVT. How can you make sure you are in compliance with the approval when operating the ballast water treatment system?
So that sort of dovetails from the previous question. The UVT numbers that have been bantered about are largely a bit distracting, because UVT, as I stated earlier, is one of only about 4 or 5 factors that affect the actual amount of UV that's placed into the reactor. For most vessels, they have no idea what the UVT of the water that they are sailing in is. Ships just don't measure UVT. And UVT is a very tricky thing to measure in an inline instrument. It is more accurately measured taking a water sample, a still water sample, and then shooting a defined UV light through it and measuring the amount of light that comes out the other side. We utilize the UV intensity sensor and a 2-stage power, as we talked about, and then we have what we term the treatment alarm, which is an alarm that goes off and provides owners with the feedback that the water treatment, or water quality rather, is not sufficient to allow a sufficient amount of dose to get distributed into the reactors. We have this alarm on a number of our ships, and our owners report back that this alarm does not go off often, if ever. And it's largely, we at Hyde Marine over the last couple of years have been collecting water samples from many different ports and have been analyzing the water quality in those ports. And largely the low UVT readings that you've heard are not necessarily indicative of what we find at most ports that we've visited.
The burst and inline UV chamber you use is normally installed with several pipe diameters ahead of and after the chamber. I know that installations vary widely. Do you consider the hydraulic challenges through the chamber for customized installs?
Absolutely. The guidance that we provide for the old Burson chambers, we don't install those typically anymore. We've shifted away from that particular reactor, but we do provide a guidance for a length of time. However, our computational fluid dynamics does not assume that there's any pipe diameters fore or aft of the reactor. We utilize some flow conditioning nozzles, both at the inlet and outlet of our reactors, in order to help to drive flow in the direction and in the flow that we want. So the design of our reactors is a significant part of the design of the Hyde Guardian and is very important to our overall success.
Has Hyde had any specific problems during commissioning or startup of systems?
That's a pretty good question. During the installations and startups, one of the things that we have observed a number of times is that often the yards and the installation contractors don't adequately consider line flushing in advance of starting up systems. We have altered our installation and our commissioning checklists accordingly, but one thing that's very important, because we've had experience where we've seen boards and wrenches and scaffold clips and other sundry objects inside of our ballast water treatment systems during startup after installation or repair periods. So that's a very critical thing to do, and to make sure that the lines are properly flushed prior to startup and certainly prior to installation of our UV lamps.
Does Hyde Marine have a ballast water management plan that can be looked at as an example?
Absolutely. Hyde Marine does have a template, a ballast water management plan that can be accessed, and we'd certainly be willing to assist any owners with that. There will be some contact information here at the end of the slideshow. Please, either through our website or through the contact information, get in touch with one of our sales agents, distributors, or one of our direct sales managers, and they can certainly get you a copy of that plan.
Do ballast tanks need to be cleaned before commissioning?
Yes. Typically, as part of the installation process, all sediments in the ballast tanks should be removed. And this is largely because organisms can remain inside the sediments, particularly larger organisms than would normally pass through the primary stage filter. And those organisms, because on discharge you wouldn't normally use the filtration stage, those organisms can contaminate the samples, particularly if you are taking initial readings at the initial discharge in order to ensure that your system is operating.
Could a pressure regulator be used to limit flow to only allow design flow?
A pressure regulating device is not a very good device for eliminating overpressurization. It certainly can be used to regulate flow. At Hyde Marine, we're working together with a valve manufacturer to put together a flow-limiting valve in our system that we have a high degree of confidence in that does not limit the pressure, and so it doesn't create the dangerous pressure spikes, particularly if the flow is restricted at the opposite end of the pressure regulator, because then the pressure can equalize across the regulator, as those are typically orifice or some other type of flow restriction device.
Does Hyde have 3D models of their system components so that engineering firms can use them in evaluating installation layouts in 3D models?
Absolutely. We have 3D models that have been created for every one of our components and all of our systems, and those models are available through our engineering partners or to our engineering partners for their use in developing plans. Again, if you have interest in getting some of those for ship application purposes, please contact one of our sales agents or our distributors or Hyde Direct Sales at hydemarine.com, and we can certainly get you in touch with the people who can get those for you.
What are the pitfalls you can encounter in EX installations?
So explosion-proof installations are a unique animal. There are many different things that need to be addressed with that. I think the key in any EX environment, and we have a number of different EX solutions, including some LPG tankers, some oil tankers, and some other chemical tankers and such, is to address the issues with the class society and the owners as part of a hazard ID analysis, a hazard, and make sure that during the hazard that you consider all of the different potential issues and problems that may come in. At that point, it's very critical the operation of the system and that the operators are familiar both with the EX requirements and the system requirements. Hyde Marine has obtained both the ATEX and IEC EX certification for our equipment, and we're certified to be installed anywhere on any vessel. But there's still, even though we have those certifications and even though we have the experience of doing those, it's still important to look at the hazards and look at the requirements on a case-by-case basis as part of the initial design phase.
Thanks, Mark. It looks like there aren't any further questions. We appreciate everyone dialing into this webinar. We will post the slides and recording of this session up on our website in the Hyde Marine Academy section. There you can also find the last 2 webinars that we've hosted. If you want additional information, you can go to our Facebook and LinkedIn pages. And if you happen to be at SMM in Hamburg next week, please visit us. We are at Hall A1, booth 413. Again, if you have questions, feel free to email us at sales@Hyde Marine or contact a local agent, which can also be found on our website. Thank you, everyone.
A chairperson has ended this conference. You will now be disconnected.